Here's a quick tutorial on how to use Gephi filters to make a big network more manageable. I've loaded up a network here that has 6,800 nodes and about 9,000 edges. Right now it's just in the default layout, and if we try to visualize that, I'll just use Gephi as a starting place. It kind of explodes out for us, but we're not going to end up with anything that's actually all that useful. We kind of just have a ball because there's so many nodes and edges. So there's a few ways that we can filter this. To look at the filters, you want to go to the right side of the screen, and you'll see we have the statistics window, which you might be used to, and then the filters tab here. When you're looking at filters, you have a bunch of options, and I'd encourage you to explore the options that are in here. I often work with topology options when I'm trying to filter a network down to be more manageable. So if we click on the tab to look at all the options under topology, we see a lot of things listed, and I always like to start with the giant component. That'll filter out any of those nodes that aren't connected into the main cluster, since they tend not to really contribute to the main analysis that we're doing. I'll drag that down into the queries window and drop it where it says drag filter here. Now the giant component is there, and I can just click the filter button, and you saw some of the nodes disappear. And if we look up here, we can see that now our number of nodes and edges is reduced, and it's telling us what percentage of them are visible. If I want to say more, I can click the arrow on giant component, and this says drag subfilter here, which means if we want to filter beyond just looking at the giant component, we can add something else. Let's see what we get by just running our layout algorithm again. So you can see now that we've filtered out nodes, we're starting to get a little bit more separation. And if we click the zoom here to fit this more in the window, we're starting to see some patterns emerge. Specifically, we're seeing a lot of these fan-like features. And this happens when you have a node that's connected to a lot of other nodes that don't have any other connections. So basically you have a hub that's connected to a lot of nodes with a degree of 1. This network happens to be built out of email communications, and so essentially we're hitting the edge of our data set. We have data for this node, and we know that it's emailed all of these people, but we don't have any data for them, so we don't know who they've emailed back. This can be really distracting in a network, and so one thing we might want to do is filter out those nodes that have a degree of 1. They're making up most of these fans that we're seeing spread out all over the network. We can do that with the degree range filter. We're going to drag that into the subfilter. So first it'll do the giant component, and then it will filter the degree range. If I click on degree range, I have a slider down at the bottom where I can pick what I want, and I can slide that to whatever point I want. So if I pick only nodes with a degree of 64 to 172, we can see that a very small percentage of my network is still available. What I actually want to do here is just nudge that up to a degree of 2, and now my network is a lot smaller. Again, if we look at the nodes and edges, we've dropped down to about 30% of the nodes and about half of the edges. And that gives us a much more manageable network. So if I run the layout algorithm again, our network is going to contract and lay out into a much more reasonable shape. Now what I can do is actually run some statistics. You want to run the statistics after you've done the filtering, because otherwise you end up with statistics on the whole network that aren't really reflective of the graph you're looking at. So first I'll zoom back in so we can see all of what we're looking at. Then under statistics, I'll run the network diameter. That'll give us betweenness and some other centrality measures. And then finally I'll run the modularity. I think for this network a value of 5 for the resolution tends to work best. Once I've run that, I end up with 9 communities, which is a good number for visualization. Finally, I want to apply that. So I'm going to color the nodes by the modularity class, which will color them by cluster. This is the initial set of colors it gives, and I usually just default to that. Note that every time you rerun this, the modularity class colors will change. So once I apply that, we can start to see that we've got some interesting clustering happening. I'm also going to change the size of the nodes by clicking on Ranking and change the size according to betweenness centrality. These are the default settings that I tend to use. I keep the minimum size at 15 so we can see all the nodes, and put the max around 80. And now we can see those big nodes with high betweenness really popping out. The nodes are a little bit bigger with that minimum size of 15, so the colors become clearer. And now we have a really interesting picture to look at. If you want to finalize this and make it pretty, we can go to the preview window, click refresh. So if we change the edges to rescale the weight so we don't have those huge edges dominating our picture, uncurve those edges to make it a little more natural looking. Now we've got a really nice network where we can clearly see the colors that represent different clusters of people, and that gives us some insights to start probing the content of the network a little more deeply.